Okay, this is the Unit 1, Lessons 13 through 15 practice quiz. And so the first couple questions on here are from Lesson 13, and they're going to be perfect roots. So when we look at question 1, and it says we have the negative square root of 324, basically for any of these problems, what you want to do is take the number that you're given and try to break it down into its factors. So you can see for these questions that I've done that over on the side. 324 is 18 times 18, and I could break these numbers down more, but the fact that there's two factors of 18 shows me right away that 324 is a perfect square. And since I'm just finding the square root of 324 is just 18, and there's a negative sign in front, so your answer is negative 18. For question 2, we have to do the fifth root of negative 243. And so again, 243, if you break it down to its factors, is just 3 to the fifth power. And because we're doing the fifth root, and this is 3 to the fifth, our answer is going to be 3. The negative sign in here means you have to think about, if I did negative 3 times itself 5 times, would I end up with a negative answer? And hopefully you realize that yes, you would end up with a negative answer, because if you have an odd number of negatives, you have 5 negatives, your answer is going to come out negative. So it's okay to have a negative inside the root if the index is odd. And so your answer for this one is negative 3. When we go down to question 3, we've got the square root this time of 16m squared over 25. So over here on the side, I broke down each of those pieces of the fraction. 16 is 4 times 4, it's a perfect square. M squared is m times m, it's a perfect square. 25 is 5 times 5, and it's a perfect square. So my second step of simplification is I'm going to take each of the individual factors, the 4, the m, and the 5, and make a fraction, and then square the whole fraction. And then the square and the square root cancel each other out, and we're left with just 4m over 5. And we would need an absolute value sign around this answer, which I didn't put, just because the index is an even index. So make sure when you're doing your real quiz, you put absolute value around your answers when the index is even. Question 4, we have the third root this time of 343d to the sixth power. So again, I took 343 using the exponent properties poster in the class. I noticed that 343 was 7 to the third power. So because this is something to the third power, I wanted to put d to the sixth as something to the third power. And so using another property from the exponent properties poster, I realized if I made this inside thing d squared, so if I have d squared to the third, you are multiplying exponents. 2 times 3 gives you the 6. So I now have it set up as something to the third and something to the third. So I'm taking each of those pieces, 7 and d squared, putting them together and raising them to the third power. And then the third power and the cube root cancel each other out, and we're left with just 7d squared. This time we do not need an absolute value because the index is odd. Okay, so all of those problems 1 through 4 were from lesson 13. Now we're getting into problems from lesson 14 where we don't have perfect roots. We're going to have to break stuff down more and find the perfect root that's buried inside the number that we're given. So for question 5, we have the cube root of 128. So over here on the side, I broke down 128. It's 64 times 2. And I'm happy with this because 64 is a perfect cube. It's 4 cubed. So I'm breaking this down into the cube root of 64 times the cube root of 2, because 64 times 2 is 128. The cube root of 64 is just the number 4, and we're multiplying that by the cube root of 2 because we can't break this piece down anymore. So our final answer is 4 times the cube root of 2. For question 6, it's the same process. We want to find a perfect cube that's a factor of negative 5,000. So over on the side, I noticed that 5,000 is 1,000 times 5, and 1,000 is a perfect cube. It's 10 cubed. So I broke this down into the cube root of negative 1,000 times the cube root of just 5, not negative 5. The cube root of negative 1,000 is negative 10, because you could have negative 10 times negative 10 times negative 10 and get negative 1,000. And then the cube root of 5 is just left over. So our answer is negative 10 times the cube root of 5. For question 7 now, we have, this is just one term, 2 root 24 times another one term, 7 root 18. So we are just multiplying 2 times 7 and root 24 times root 18. You are not foiling for this kind of problem. The only time you foil is when you have two terms inside your parentheses. The way you can tell there are two terms is if they are separated by a plus or a minus sign. Please do not make this mistake on the real quiz. So the first thing I did, 2 times 7, that gave me 14. Then I broke down the root 24 over here. That's root 4 times root 6. 4 times 6 is 24. Root 4 is 2. So this is just 2 root 6. And I broke down 18 as root 9 times root 2, because 9 times 2 is 18. Root 9 is 3. So you can see I have 2 root 6 times 3 root 2. And then I multiplied these together. 2 times 3 is 6. Root 6 times root 2 is root 12. And then I noticed, well, actually I did 6 times 14, I got 84. The root 12 has another perfect root that's buried inside of it. 4 times 3, root 4 is my perfect root, and that's 2 root 3. So I have 84 times 2 root 3, and then 84 times 2 gives me 168. So my final answer is 168 times the square root of 3. Now onto the second page, number 8. Here we have two terms because we have a plus separating them and a minus separating these. So we have 2 times 2. We're going to be foiling. So I FOILed this out. I showed the process of what I'm multiplying by. I ended up with 5 minus root 7 plus 5 root 6 minus root 42. I thought about trying to break down 42, but since that was just 6 times 7, it's not like I can break 6 down and find a perfect root. And I can't break 7 down, so I could not break the 42 down. So none of these are like terms. I can't combine anything, so I just have to leave it as is, and this is my final answer. But when you do the real quiz, you need to check and make sure to see if you can combine any terms, see if there's any like terms, or see if you can break anything down any further. For question 9, we have 3 plus the square root of 2 divided by 2 minus the square root of 2. Anytime you have a complex fraction like this, where you have multiple terms in the denominator that has a root in part of it, you need to multiply by the conjugate of the denominator. So over on the side, the conjugate of 2 minus root 2 is 2 plus root 2. So I'm multiplying the top and bottom by the conjugate of the denominator, and then we're foiling. So I FOILed the top, I FOILed the bottom. You can see my work over here. The numerator simplifies to 6 plus 5 root 2 plus 2. We had a 3 root 2 and a 2 root 2. That makes 5 of the root 2's. The bottom, the O and the I are always going to cancel out when you do FOIL. That's why you do a conjugate. Then we had 4 minus root 4. Root 4 is 2, so we just have 4 minus 2. When we combine all this stuff, you get 8 plus 5 root 2 in the top divided by 2. You can leave your answer like this, or you could break it apart and say 8 divided by 2, which is 4, plus 5 root 2 over 2. You can't simplify that, but it's fine also just to leave your answer this way. Question 10, now we've got a word problem, but it's not a difficult word problem. It says the formula S equals 2 times the square root of 5L estimates the speed S in miles per hour of a car when it leaves skid marks L feet long. Use the formula to write a simplified expression for S if L equals 85, and then evaluate S to the nearest mile per hour. So the first thing I'm going to do, I've wrote my formula down. I put in 85 for L. 5 times 85 is 425. And then I thought, can I simplify the square root of 425? So I broke 425 down, and it happened to be 25 times 17. And I know 25 is a perfect square, so I'm happy with how I've broken it down. So I'm going to just split it up into 2 times root 25 times root 17. Root 25 is 5. 2 times 5 is 10, so we have 10 root 17. And then evaluating that to the nearest mile per hour just involves putting this number in your calculator, and I got about 41 miles per hour. The squiggly equal signs just mean about equal to. For question 11, it says we need to write the expression in radical form. So if we have an exponent form, we're putting it in radical form. Or if we have a radical, we're going to put it in exponential form. So we're just switching forms. So first we have n to the third to the 2/5 power. So I took this, that means I need to multiply the powers 3 times 2/5, and that gives me 6/5. So that is exponent form of simplifying this, and I need to put this in root form. So putting it in root form will be the 5th root of n to the 6th. Then we need to simplify it. I can break the 6 down into the 5 n's with 1 left over. The 5th root of n to the 5th cancels out to just n, and then we'd have the 5th root of this n, the extra 1, left over. So this is our final answer. For number 12, we've got the 5th root of 2a to the 10th times b. So first thing I'm going to do is break it up into each piece, give each one its own piece. So they have the 5th root of 2 times the 5th root of a to the 10th times the 5th root of b. And my goal is to put this thing in exponential form. So if the only thing I can see that simplifies is the 5th root of a to the 10th. 10 divided by 5 is just 2, so this is a squared. So I'm going to have that out in front. And then I can't simplify the 5th root of 2, can't simplify the 5th root of b, so I'm going to put those pieces together. I just realized I have a mistake here. This is 2. This should be a 2 also, the 5th root of 2b. So my final answer when I put it in exponent form, again, this should say 2b to the 1/5 power, not 5b. It should say 2b, and then times a squared, and that would be your answer. This is my radical form version of the answer. This is my exponential form of the answer. Question 13, we have a fairly complicated expression. It says t to the 2/3 divided by 5t to the 1/2 power times t to the negative 3/4 power. And so the first thing that we want to do is simplify the bottom. We're going to combine these. Anytime you have the same base to a power, you can add the exponents. 1/2 minus 3/4, or 1/2 plus negative 3/4, however you want to look at it. I got a common denominator, and I got negative 1/4. So when I combine these, I have 5t to the negative 1/4 power. And then using the exponent property, when you have the same base, both t, you have a fraction, you can subtract the exponent. So it's 2/3 minus negative 1/4. That's what I did over here. And this is 1 over 5, so that's why I have the 1/5. 2/3 minus negative 1/4. I did that down here. 2 minus signs makes a plus sign, so I have 2/3 plus 1/4. Got a common denominator of 12, so 8/12 and 3/12 makes 11/12. My final answer is 1/5 t to the 11/12 power. And the last question, another word problem, says the amount of current in amps I that an appliance uses can be calculated using the formula I equals P divided by R to the 1/2 power, where P is the power in watts and R is the resistance in ohms. How much current does an appliance use if P equals 500 and R equals 10 ohms? Round your answer to the nearest tenth. So first thing I did, anytime you have a word problem with a formula, write the formula out. Then you plug in the values you're given. They give you P is 500 and R is 10. 500 divided by 10 is 50. And we're taking the 1/2 power. The 1/2 power is just the square root. So you go to your calculator. The square root of 50 is 7.07. And I'm rounding to the nearest tenth. That's 1 decimal place. So the 7 bumps us up to 7.1 amps. Because my answer is in I, units of I, and I is amps. Make sure you throw units on your answer for a word problem. Okay, that's the whole practice quiz for Unit 1, Lessons 13 through 15.